This section is on area between two curves. We've been finding the area between a curve and the x-axis using FTC, Fundamental Theorem of Calculus. What we now want to do is find the area between two curves. And so we have this formula to find the area between two curves. We use the integral from a to b of f of x minus g of x dx. And so if you're doing this by hand, you would probably want to go ahead and subtract the two functions together and then take the integral. But you'll see when we do them in Excel, we'll actually take the antiderivative of this one, evaluate it from a to b, and the antiderivative of this function, evaluate it from a to b, and then subtract. And both of those are fine to do. The first example says find the area bound by the graph of f of x equals 2x minus 1 and g of x equals x squared minus 4, and the vertical lines x equals 1 and x equals 2. Okay, so if we did this by hand and we want to find the area between these two curves, we would use this formula, the integral from a to b of f of x minus g of x dx. So from 1 to 2, we have f of x 2x minus 1 minus g of x x squared minus 4 dx. So if you're doing this on paper, you're probably going to want to just combine these like terms, which would be negative x squared plus 2x minus 1 minus a negative 4 is positive 3. And then take the antiderivative, which would be negative x cubed over 3 plus 2x squared over 2, which is just x squared plus 3x, and evaluate it from 1 to 2. So if we did that, we're going to have negative 1 times 2 cubed over 3 plus 2 squared plus 3 times 2 minus parentheses negative 1/3 times 1 cubed plus 1 squared plus 3 times 1. So then we'd have negative 8/3 plus 4 plus 6, which is 10, minus negative 1/3 plus 1 plus 3, which is 4. And then let's distribute the negative. So then you have negative 8/3 plus 1/3 is negative 7/3, and then 10 minus 4 is positive 6. So that's negative 7/3 plus 18/3, which is a positive 11/3. Okay, so we did this problem, and I wanted to show you what it looks like on a graph. This is y equals 2x minus 1 here, and this is y equals x squared minus 4, and this is x equals 1, and this is x equals 2. So this sort of brownish area here is the area that we just found, and it's 11/3. But I do want you to notice that this is the x-axis, and so you might think, well, there's some positive and some negative, some values under the x-axis. Well, you don't really need to worry about that, and I just illustrated this by adding 5 to both my functions, and it shifts up both my functions, and you can see this area doesn't change. So we just need to follow the formula and find the area under the curve. The other thing is, how do you know if you have found the function that's above the other function? Well, we'll see in Excel that if there's ever any kind of debate, you can figure it out by just looking at the values that you're getting. Okay, so here's a second example. F of x squared equals x squared minus 2x minus 1, and g of x equals negative x e to the x minus 1, and vertical lines negative 1 and x equals 1. So if we wanted to do that, it would look like this. You would find the area of the region between these two. So you would set up an integral. The lower limit would be negative 1, the upper limit would be 1, and then you're going to substitute in f of x and g of x. And the way that I've set this up is the way that we're going to do it in Excel. first example, we subtracted the functions first and then took the integral. Well, you can also take the integral of one function, evaluate it from -1 to 1, and find the area under that, and then find the integral of g of x and evaluate it from -1 to 1 and find the area under that one. And then what you can do is just look at it, and you would subtract whatever's smaller over whatever is larger. So that's how you would handle it in Excel, and I'm going to go over there and show you that right now. Okay, so to find the area between the two curves using Excel, what we'll do is we'll set up our x, and we know the lower limit's -1 and 1, and we will say anti f of x and anti g of x, and we'll take the antiderivative of the first one, which would be equals x cubed divided by 3 minus 2 times x squared divided by 2 minus 1 times x. Drag it over, and then find the area under that curve by doing the upper limit minus the lower limit. And then g of x, the antiderivative of -1 e to the x is -1 comes on down times the antiderivative e to the x to e to the x, so exp parentheses x, and then the antiderivative of -1 is -1 times x. Drag that, and that's evaluating at -1 and at 1, and the FTC, the area under the curve, is the upper limit value minus the lower limit value. And then to find the area between, you just basically look, and whichever is bigger, you would start off with that. So g of x I would click on first, and then minus the -1.33 I would go next, and that gives you your area between the two curves. Okay, if we go back to example 1 and do it the Excel way, we already know the answer is 11 over 3. Then we would have anti-f of x, which would be x squared minus x, and then evaluate the FTC, you get 2, and then the anti-g of x would be 1/3 x cubed minus 4x, and evaluate it, and FTC, subtract larger upper level minus lower limit, get this, and then the area between them would be, so if you subtracted this minus this without thinking, you get -3.66667, which is the approximation for 11/3 or -11/3. So basically, if you subtract one minus the other and get a negative, then turn around and subtract f of x minus g of x, and you'll get the positive value. You always want your area to be positive, so you really can't mess up. If you get this right and this right, if you subtract the two and you get a negative, just turn it around, or just turn it around and try the other direction. And at this point, let me make a note to tell you that WebAssign may want exact answers. So if you got 3.66667 and type that in WebAssign, it may count it wrong. If it does, it's because they want you to do it by hand and get a perfect 11 over 3, which is an exact answer. Okay, so let's look at a word problem. This one says, for a developing country's economic development board, economists and energy experts concluded that if the energy conservation bill were implemented in 2003, the country's oil consumption for the next 5 years would be expected to grow in accordance with the model R of t equals 20e to the 0.05 t. So we're talking about growth, where t is measured in years corresponding to 2003, and R of t is in millions of barrels per year. So that's our hint that this is a rate of change. Without the government-imposed conservation measures, however, the expected rate of growth of oil consumption would be given by R of t equals 20 e to the 0.08 t million of barrels per year. Determine how much oil would be saved from 2003 to 2008 if the bill had been implemented. So we can see that this is an exponential function, and this rate of growth is higher than that one, but you don't even really have to notice that. What you do have to notice is that these are rates of change, and we want to find the area between them, because the area between them is the antiderivative, and the antiderivative is millions of barrels. So I'll type all that up. The part that's really important is to understand your variables. So t is equal to years corresponding to 2003. So years since 2003. And then R of t is in millions of barrels per year. So that means the antiderivative of R of t is in millions of barrels. So what we're going to do is we're going to calculate the millions of barrels with this rate of change and calculate the millions of barrels with this rate of change and see how much more one is than the other. So set this up, we'll have t, and 2003 would be the year 0, and 2008 that would be the year 5. 5 years since 2003. And then we'll do the with the bill, and that would be 20 divided by 0.05 times exp to the 0.05 times t, and then evaluate it at 5, and then FTC means find the area under that curve, and then the antiderivative without the bill would be equals this one right here, 20 divided by 0.08 times exp, 0.08 times t, and then FTC, we already have the formula, we'll just drag it down. And so then the area between would be, and if you just look at it, you can see that this is bigger. So this minus this is 9.346 million barrels. Okay, so we want to make a statement about this. So between 2003 and 2008, 9.346 million barrels of oil would be saved if the bill had been implemented. And then right here is a visual of what's going on. So X is years since 2003, and this function, the top line here is your without the bill, and this line here would be with the bill, and this is from 0 to 5. And so what we're doing is we're finding this area in between these two slivers. And so this is the area, complete area under the curve without the bill right here, from here all the way down. And then you got the area from with the bill all the way down. And so if you take this big sliver here, this big spot right here, like that, and then you subtract out this, then you'll be left with that sliver. So that's what we're doing. Okay, here's another example. If in tests conducted by the Auto Test magazine on 2 identical models of the Phoenix Elite, it was found that the acceleration of the standard engine is given by this formula. So this is an acceleration function, and it's in feet per second, t seconds after starting from rest to full throttle, whereas the acceleration of the turbo is given by g of t equals 4 plus 1.2 t plus 0.03 t squared feet per second per second. How much faster is the turbo charged model moving than the model with the standard engine at the end of a 10-second test run at full throttle? So we have to go back and remember from test 2, acceleration is the second derivative of the position, but it's the first derivative of velocity. So this is acceleration, and if we take the antiderivative, this will get velocity. And so we want to know how much faster, there it is, that word velocity, how much faster is the turbocharged model moving than the model with the standard engine at the end of the 10-second run at full throttle. So what this is saying is, find the area under this curve and you'll have velocity. Find the area under this curve and you'll have velocity. If you subtract the two out, you'll have how much faster one is going than the other. So if we let t be from 0 to 10, because it says at the end of a 10-second full throttle run, we're going to calculate two areas under the curve. We're going to find anti-f of t, which is velocity. And so that is 4 times t plus 0.8 times t squared divided by 2. And then the area under the curve would be upper limit minus the lower limit. And then the anti-g of t would be 4 times t plus 1.2 times t squared divided by 2 plus 0.03 times t cubed divided by 3. And then the FTC formula is here. So I'm going to add this so we can keep track. Remember, anti-f of t is the standard engine, and this is the turbo engine. And if I want to find the area between the two curves, you can see which one we should click on first. The 110 is bigger than the 80. All right, and we have this. So let's look at the units. Remember, f of t is feet per second, so the antiderivative of f of t would be feet per second. Same thing with this one, feet per second. The antiderivative would just be feet per second. And so the area between would be feet per second. So that means that at the end of a 10-second run, the turbo engine car was traveling 30 feet per second faster than the standard engine car. Because this is standard and that's turbo, and turbo is clearly going faster, 30 feet per second faster. Okay, so the last example, Carl, the proprietor of Carl Williams Auto Sales, estimates that with extensive television advertising, car sales over the next several years could be increasing at a rate of 5e to the 0.3t. So this is a rate, and the units are thousands of cars per year. T years from now, instead of the current rate of 5 plus 0.5t to the 3 halves, 1,000 cars per year, t years from now. How many more cars does Carl expect to sell over the next 5 years by implementing his advertising plan? So again, we have this rate of change. It's thousands of cars per year. If you think about Riemann sums, a vertical area of a rectangle is length times width, so a vertical thousands of cars per year times a width of year gives you thousands of cars. So this question, how many more cars does car sell, means that we want to find the area under this curve and the area under this curve, and then find the area in between the two. So we'll do t, and it says 5 years, so from 0 to 5, and anti-f we'll just say before advertising, and before advertising it was this. That's the current, so we'll call this, change this to current sales. And so if we take the antiderivative of this, that'd be 5 times t plus 0.5 times t caret 3 halves plus 1 is 5 halves, or 2.5, divided by 2.5, and that's that antiderivative. And then we want to find the area under this curve, so upper limit minus the lower limit. And then with the adds, we have this function 5e to the 0.3t right here. So that would be equals 5 divided by 0.3 times exp to the 0.3 times t. And then the FTC is upper limit minus lower limit. And the area between, you can see this with adds value is higher than that, so you would just click on this one minus that one. Alright, now let's think about units. Again, the original function was a rate of change. It was thousands of cars per year. This is an antiderivative area of the curve, so this is just thousands cars. 1,000 cars, 1,000 cars. So how many more cars did Carl expect to sell? Well, the current would be 36.18 thousand. With adds 58.03 thousand. So how many more cars would be 28.8478 thousand cars. So we can go ahead and multiply this by 1,000. Oops. 21,847.8 cars. Okay, you've got 4 problems in your lab manual that you want to try, and I want you to do something that I did not demonstrate today. Hopefully you are understanding after I gave you feedback on your test. You have got to show your work. You have got to write down the derivative on your test paper, because I'm not even going to look at the Excel file for the final or for test 3. I'll just count off, I'll have to count off -5 if you miss the problem. So I did these derivatives, as I was going, basically because I'm trying to get through this video in a little faster time without having to switch back and forth. But you really need to write these on paper and write the integral, show me that you're going from 0 to 5. You get points for that. You get points for your antiderivative. So that if you kind of screw up somewhere, have a little typo, at least I know that you knew the right interval and you knew that you're supposed to take the antiderivative. You've got to write it on your test, or I cannot give you partial credit. Okay, so go ahead and complete 1 through 4, and I have some of these answers. You can go ahead and check your work.